Hey everyone, we're going to talk about redox today. We're going to talk about assigning oxidation numbers in particular. So, redox. Reduction is the gain of an electron. Oxidation is the loss of an electron. So when you put the words together, you have redox. So you typically hear that, you typically say that, and you just say redox. I'm going to go over this example in a second. I actually just want to talk about, there's a list of rules for assigning oxidation numbers. And unfortunately, yes, you have to memorize these, but there's really two or three that come into play most often, and you'll see through the examples which ones I'm talking about. So these are the rules. If it is an element or something is diatomic, its oxidation number is 0. If it is an ion with a charge, its charge is its oxidation number. Fluorine will always be -1. Oxygen is 99% of the time it's going to be -2, unless it's with fluorine or if it's H2O2. In this instance, H2O2, its oxidation number is -1. Okay, and then if something, H plus is usually +1 if it's with another non-metal. And then if something overall, if a compound is neutral, its charges must add up to 0. And then if you have an ion that is a positive or negative charge overall, all the charges must add up to that, whatever that overall charge is. Okay, so let's just look at this reaction, okay, just to kind of give you a general sense of what redox is. So you have Na plus diatomic chlorine gives us NaCl. And what I'm going to do using the red pen and write a little smaller there, I'm going to write down what their oxidation number is above it. Okay, so Na, it's an element, it's by itself. So according to rule number 1, its oxidation number is 0. So I'm going to put a 0 above it. Okay, Cl2 is diatomic. Its oxidation number is also 0. Okay, and when they come together in this compound, this is a metal, non-metal compound, so this is an ionic compound. So you would typically just look at the charges on the periodic table to determine the oxidation numbers in this case. So if you look on there, Na is a alkali metal, and that means it's group 1, which its charge is always +1. Cl is a halogen, and its charge there is -1. So here we have assigned all the oxidation states to everything in that reaction, okay? And just so you can kind of get a better visual here, what's happening to Na? Na is going from having a oxidation number of 0 to +1, which means it's giving up an electron, therefore it's becoming more positive. So when you lose an electron, this is your oxidation. The chlorine, on the other hand, is going from 0 to -1. Its oxidation number is being reduced. That is why we call reduction reduction. Because even though you're gaining an electron, the oxidation number is getting reduced. It's going down. So I'll write down red. Okay? And that's how you would do those. So let's look at, I'm going to leave the rules up here for you. Let's look at these examples now on how to assign oxidation numbers. I'm going to do the first 3, and then I'm going to pause and give you an opportunity to do some on your own. Okay, so I'm just going to solve these 3 as its own little mini problem set, and I'm going to show you the tricks I like to use. Okay, so we have F and O. Those are the 2 big ones. Fluorine is always -1, and then oxygen, for the most part, is almost always -2. So I'm going to do for these first 3, above oxygen, I'm just going to put down a -2, and above fluorine, I'm going to put down a -1. And just note, every time I write an oxidation number, this is always the number for just one of them. So even though it's CO2, this number is telling me that one of these oxygens is -2. Okay? So now we've done the oxygens and fluorines of these 3. So now let's look at CO2 in particular. So we have C. We don't know what its charge is. And for oxygen, we have two of them, and they're both -2. So according to rule number 6, this is a neutral compound. CO2 has no charge. So everything here has to add up to be 0. So what is X? And if you add up these negatives, X minus 4 equals 0. Okay, if you solve for X here, X would have to be +4. And that's what your chlorine, that's what your carbon is going to be. So that is +4. So now just do the same for B and C as well. So fluorine's -1 and there's 6 of them. So that would be F. I'll just put down, actually I'm not going to put down F. I'm just going to put down -6. And then we don't know what S is, and there's 1 of them. So X minus 6, it's neutral, is 0. That means X would have to be +6. Okay, and lastly, NO3 negative. Okay, we already know oxygen is -2. So 2 times 3 is -6. We only have one N. And then equals, unlike before when these were neutral, okay, you'd equal them to 0. But since it's a -1 charge, you're going to equal it to -1. So now just solve it. X minus 6 equals -1. Add 6 to both sides. X equals +5. Okay, now please attempt D through G. Okay, pause me, and then I will work through these when you're ready. Okay, hopefully you've attempted these. So I'm going to use the same strategy. I'm just going to find all the oxygens and make them -2. Okay, and then I'm going to distribute out the charge. So -2 times 3 is -6. And then we only have one S. X minus 6 equals 0. Okay, and there's no charge. So S would be +6 there. Okay, similar deal here. -2 times 4 is -8. There's one S. X minus 8 equals, we have a charge though, of -2. Okay, get X alone. X equals +6. Okay, let's look at this one now. -2 times 5 is -10. Okay, and normally we've done X, but if you look here, there's 2 N's. So it's going to be 2X minus 10 equals 0. So 2X is going to equal +10. Divide both sides by 2. X equals +5. And that is your charge for one of the nitrogens. Okay, this last one's a little tougher, and we have not actually talked about how you solve one of these. But I just wanted to show you in general, if you're able to piece together by some of these rules, what would happen here, okay? And so what you do is, you're still, that -2 is the oxygen. So -2 times 4 is, you have -8. There's no charge, so it's all going to add up to 0 still. Okay, now we have to figure out what H is and what S is, because we have, for the first time, we have 3 species total in this compound. So just look and see if any of these else have any other rules. And if you look here, hydrogen has a rule. If it's with other non-metals, which these all are, it would be +1. So we know what hydrogen is. It's +1, and there's 2 of them. So that gives us +2 to this equation. Okay, And that just leaves us with this S. And there's only one of them, so I'm going to make it X. So X plus 2 minus 8 equals 0. So that is X minus 6 equals 0, in which case X would be plus 6. Okay, and this also tells us something. This is all about someone is being the electron hog. Okay, in this case, oxygen's the one who has the negative charge. So oxygen's getting all the electrons here. In these circumstances, when you have 3 or more, just know only one of them can be negative and everything else is going to be positive. Okay, there you go. There is assigning oxidation numbers. I'm going to do more of these in a different video coming up with the oxidation numbers with equations. So please check that out if you need a refresher, if you want to learn it. Have a good one. Bye.